So in this video, we're going to go over Dalton's Law of partial pressures, and actually we're going to be able to apply it to the concept of collecting a gas over water, which is a lab that you guys are going to be doing in class. So Dalton's Law of partial pressures is actually awesome because what it tells you is that the total pressure that's exerted on a system, that equals the sum of all of the individual pressures that gases exert. So for example, if you have in the atmosphere oxygen, nitrogen, helium, all the different gases, they do not interact with each other, which we saw when we're talking about ideal gases. They're not going to be attracted to each other. So instead, all of their individual pressures simply add up together to give you one total pressure. So that makes a really easy problem for us. So let's look at an example. It tells you air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen at 101.30 kilopascals of total pressure if the partial pressure of nitrogen, carbon dioxide, and other gases is 71.10, 0.040, and 0.94 kPa respectively? Well, I know my total pressure is 101.30, and I know the partial pressure of all the other guys except for oxygen, so I'm going to add up all of their pressures plus the partial pressure of oxygen. So all I have to do to figure out the partial pressure of oxygen is take the total pressure and subtract from it the partial pressure of each of the other gases, and that gives me a partial pressure of 21.22 kilopascals. So that's all there is to Dalton's Law of partial pressures.